Hi everyone, and welcome to Physics Exam Prep. If you're new here, this channel is all about helping you master physics exam questions, especially the more challenging and classic ones from past papers. These are exactly the kind of problems your teacher might choose for your final exam. Today we're tackling a slightly more difficult SUVAT problem. In simpler ones, the quantities you plug into the equations are easier to spot. But here, we'll need to interpret the situation carefully to work out what's given and what's not. Along the way, I will introduce an important technique, defining the positive direction, a skill that helps avoid sign errors. Before we dive in, take a moment, pause the video, read through the questions, and see if you can spot the SUVAT quantities. You might also sketch a quick diagram. It really helps you visualize the motion. How did it go? Let's compare notes. Here's my diagram of the motion with upwards defined as the positive direction. This step is essential when working with vectors like displacement, velocity, and acceleration. Since the volume in the question is moving upwards at a constant velocity of 10 meters per second, its velocity is a positive number in our sign convention. All right, let's read question together. The first important phrase is object released at rest relative to the balloon. In many simpler SUVAT problems, release at rest means the initial velocity is 0. But here, it means the object starts with the same velocity as the balloon. So the initial velocity of the balloon is 10 meters per second upwards. Next, the question says there is no air resistance. That tells us weight is the only force acting on the object after release, so the object experiences the acceleration due to gravity, which is 9.81 meter per second square, downwards. I made a mistake here. Did you see it? As we've defined upwards as a positive direction, this 9.81 should be negative. If you're following so far, you're doing great. Here is another piece of information. We are told that the object starts 120 meters above the ground. So, should the displacement be positive 120 or negative 120? Think about this carefully. This is where your sign convention matters. The object is moving downwards, so displacement is negative 120. Let me know in the comment if this part is still not clear to you. The next part is logic chain. This is where I'll take you through the reasoning steps for answering the questions, and you'll be able to apply it to many other similar problems. For SUVAT problems, it is a good habit to identify what's given and what's needed. In this case, we have S, U, A, and we need to find T, the time taken for the object to hit the ground. We have no information about V, the final velocity. Based on this, we choose the right SUVAT equation, S equals to UT plus half AT squared, because it includes S, U, A, T, and it does not require V. A common mistake here is to assume the final velocity is 0. That's not correct. The final velocity here refers to the velocity just before hitting the ground, and it will be non-zero. We will go through the solution in a few seconds. If you'd like to try on your own first, just hit pause. Alright, let's walk through the solution. Here is the equation, and let's plug in numbers. You can see that I kept the negative signs for displacement s and acceleration of freefall a. Let's rewrite the quadratic equation and simplify. Here we need to apply knowledge from math class. We apply the quadratic formula and plug in numbers and do some calculation, and you'll find two solutions. Only the positive root makes physical sense. So the final answer is 6.07 second. Let's have a quick recap. Here are some key takeaways from the lesson. First, you need to define the positive direction first when you get the SUVAT problem. Second, make sure every vector quantity sign matches your definition. Third, choose the SUVAT equation that contains only the quantities you know and the one you need. If you find the sign conventions tricky, don't worry. That's a skill that gets easier with practice. If it's not quite making sense yet, bookmark this one and come back after a bit of practice. It'll click next time.